Hello students. So today I'm going to teach you about electronic configuration according to subcells and block of elements. So this portion is taken from classification of elements. Okay. So look at here. Electronic configuration. Electronic configuration. Okay, how do you define electronic configuration? Electronic configuration is defined as the systematic distribution of electrons in different energy levels is called electronic configuration. What is given here? The systematic distribution of electrons in different energy levels is called electronic configuration. You know, electrons are present in atoms. So, the central part of the atom is nucleus, and outer part is called electron cloud. So, these electrons are found in a spherical path. They revolve around the nucleus in a spherical path that is called shell or orbit. And each shell or orbit is divided into smaller regions. These are subcells. We know there are four subcells. Four subcells. They are S, P, D, F. S, P, D, F. It means K cell, it has got only S orbital, L has two, S and P, SKLM has S, P, D, and has S, P, D, F, O has S, P, D, F, P has S, P, D, and Q has 2, S, P. So K is first cell from the nucleus. It is second, third, fourth, fifth, sixth, seventh. If I write 1, 2, 3, 4, 5, 6, 7, these are energy levels. These are energy levels. So students, at first electrons are filled in K, in S, in second L, in L. Okay, it can be written like this: 1s at first, 2s, and 2p, right? Then 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s, 7p. These are the subcells. 1s2, 7p. This is 7p. Okay. Do you know how many electrons can be fitted in S, P, D, and F? In S, 2, maximum 2 electrons. In P, 6 electrons. D, 10 electrons. And F, 14 electrons. Okay, 14 electrons. S cannot hold more than 2. P cannot hold more than 6. D cannot hold more than 10. F cannot hold more than 14. In our class, we are going to study or discuss electronic configuration according to subcell. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 5s, 5P, 5D, 5F, 6S, 6P, 6D, 7S, 7P, 7D. In this connection, let's discuss about Aufbau principle. AUFBAU. Aufbau principle. What does it mean? Aufbau principle is the way which gives us the idea how the electrons are distributed or kept in the atom systematically. It was given by German scientist Wolfgang Pauli. Okay? What did Wolfgang Pauli say? He said electrons are not filled in all energy levels at once. He said electrons are filled first in lower energy levels and afterwards in higher energy levels. Now question arises, which are lower energy levels and which are higher energy levels? For that he gave one technique. What is the technique? He wrote all those orbitals. I wrote there M1s, 2s, 2p, 3s, 3p, 3d. Already I have written over there, no? Then 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6d only. Then 7s, 7p. Now he gave us one idea how to make energy levels. So he used arrow like this. Look at here. Arrow always goes in straight line. These are energy levels. Which is the weakest energy level? 1s. It means lower energy level is 1s, higher energy level is 7p. So according to Wolfgang Pauli, first electron is filled in 1s, then it will be filled in 2s, then 2p, 3s, 3p, after 3p, 4s, after 4s, 3d. Look at it, 3d. After 3d, 4p, then 5s, after 5s, 4d, then 5p, then 6s, after 6s, 4f, then 5d. Look at it, 5d. Now 6p, 7s, 5f, 6d, 7p. So Wolfgang Pauli's Aufbau principle says that electrons are filled in 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 4p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. After filling the electrons in lower energy level, it will fill in higher level. Dear students, you must know first 20 elements, hydrogen to calcium, and their electronic configuration according to subcell. So right now we are discussing how to write electronic configuration of first 20 elements. Once, let's remember this: 1s, 2s, 2p, 3s, 3p, 4s. For first 20 elements, you have to remember this much only. Once again, let's say 1s, 2s, 2p, 3s, 3p, 4s. 1s, 2s, 2p, 3s, 3p, 4s, finish. That was only 1, 2, 3, 4, 5, 6. Shall we begin now? Okay. So I'm going to guide you how to write electronic configuration of these elements. Tell me the first element, hydrogen. Second, helium, lithium, beryllium, boron, carbon, nitrogen. Hydrogen atomic number is 1, 2, 3, 4, 5, 6, 7. Isn't it? So, can you tell me which is the first energy level? The first energy level is 1s. And here is 1 electron. We write 1 electron. 1s1. That is the electronic configuration of hydrogen. Helium, 1s. Here 2 electrons, 2. 1s1, hydrogen. 1s2, helium. Simple. Lithium. First lithium, for lithium we write 1s. What is the electron holding capacity of s? 2. Maximum 2 only. But here are 3 electrons. Now what to do? 1 more electron. What comes after 1s? 2s. Good. 2s1. 2 plus 1, 3. Here also 3. Then what about for beryllium? First 1s2. 2 electrons gone. Still 2 are left. 2s2. Okay? For boron, remember 1s2, 2s2 only. Don't write 2s3. Why? Because s cannot hold more than 2 electrons. 2s2. Then what comes after 2s? 2p. 2p1. Now see. Hydrogen 1s1, helium 1s2, lithium 1s2, 2s1. 2 plus 1, 3. Beryllium 1s2, 2s2. By counting these powers, we can get the number of electrons. Say beryllium 1s2, 2s2, 2p1. Don't write 2s3. Capacity of S is only 2 electrons. Now carbon, what do you do? 1s2, 2 gun. After 1s, there is 2s2, 4 gun. Then how many electrons are left? 2. 2s2. Is it okay? So electronic configuration of carbon is 1s2, 2s2, 2p2. I wrote here 2s2 is wrong. 2p2, 2p. This is nitrogen 1s2. Now you say 2s2, 4 gun, 2p3. Can you write 2p3? Why not? Because the electron holding capacity of p is maximum 6. Here only 3 we can do. Suppose now you are writing neon. Neon, let me tell you. Neon means the atomic number is 10. Then 1s2, 2 gun, 2s2, 4 electron gun, 2p6. 6 plus 2, 8, 8 plus 2, 10. That is the electronic configuration of neon. Let's try sodium now. Sodium means 11. 1s2, 2 electrons gun, 2s2, 2 more gun again, 4 out of 4, out of 11, 4 gun means 7 left. What comes after 2s? 2p6. Don't write 2p7 because the electron holding capacity of p is 6 only. 10. And what comes after 2p? 3s. Third energy level here, 3s1. 7 plus 4, 11 electrons. Simple. Next, let's see aluminum. Aluminum is 13. What are the electronic configurations? 1s2, 2 electrons gun, 2s2, 4 gun, 2p6, 10 gun, 3 are left. So 3s3. Can you write? No, because in S we can get maximum 2 only. After 3s, which subset comes? 3p. So 3p1. Okay. So 1 plus 2, 3 plus 6, 9 plus 4, 13, 13. In that you have to. Let's see argon. For argon, what do you do? You have to know its atomic number 18. 1s2, 2s2. What comes after 2s? 3p6, 10 gun. After 3p, sorry, not 3p, 2p. Then 3s2, 3p6. Because after 1 is 2s, then 2p, 3s, 3p. 2 electrons are here, 2 are here, 6, 2, 6. 6 to 8, 14 plus 4, 18. Now calcium is right. Calcium atomic number is 20. Why am I giving the gap? So that you can practice yourself. Remember. So 1s2, 2s2, 2p6, 3s2. 1s, 2s, 2p, 3s, 3p6. 2 plus 2, 4, 4 plus 6, 10, 12 plus 6, 18 gram. Now, which orbital comes after 3p? 4s. 2 electrons are there. Then, that is the orbital electronic configuration of calcium. What is it? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Sodium 1s2, 2s2, 2p6, 3s1. Isn't it? Okay, students. This is electronic configuration of the first 20 elements. Now I am going to guide you about block of elements. Block, B-L-O-C-K. Block of elements. How many blocks are there in the periodic table? 4 blocks. 4 blocks of elements. Altogether 118 elements are there. They are kept in 4 blocks. What are they? In S block, P block, D block. We don't write here capital, okay? Small s, small p, small d, small f. S block, F block. So what do you mean by S block element? Students, look at here. If you talk about the sodium, its valence subcell is S. Is here S or not? But if you talk about aluminium, valence subcell is P. If you talk about argon, valence subcell is P. Again calcium, S. Now, if you talk about block, we have to look at the electronic configuration. Where are the valence electrons, the outermost electrons located? If the outermost electrons are located at S orbital, that belongs to S block element. If the valence orbital lies in, valence electron lies in P orbital, P block element. At last, if there is D block element. At last, if there is F block element. So there are 4 blocks in the modern periodic table: S block element, P block element, D block element, and F block element. Which elements, which groups fall under S block? Group IA and IIA. First A and second A. B block 3A2, 3A, Rajesh Vaidal, 4A, 5A, 6A, 7A, and 0. D block 1B, 2B, 3B, 4B, 5B, 6b, 7b, and 8. These are all our D block elements, they are maximum. And F block, lanthanides and actinides. Lanthanides and actinides are F block element. Simply you have to keep in mind, S block element has valence electron in S subcell, P block in P subcell, D block D subcell at last, and F block F subcell at last. Dear students, I hope you might have got some idea about two headings, that is electronic configuration according to subcell and block of elements. If you have got any comments, please comment over there, and what type of video you want, you can write. I will make accordingly. This much for today. Have a great time. Thank you.